go to my view, is it? Can you see if you can get to the view and to go to full screen? Oh, see, it's something with the board. Okay. Well, this is very disturbing. Just have to control it. That's good. That's recording that. Okay. All right, guys. Sorry, we're back. Oh, I thought you were asking a question. Okay, but we are recording, so can we please focus? All right. If we want f of -1, we take f of 1 plus the change in f from 1 to -1. It's okay to leave it like that. If you want to switch it to minus the definite integral from -1 to 1, you can. It will be the same. Just you don't have to. Yeah. The lower limit will always be, as long as you keep this plus, the same number as what's in here. Okay? And the upper limit will always be the x value over here. So yes, people that got -0.31. Questions on that one? Yep. Okay, so the higher number has to be on top when you're going to evaluate the definite integral. How? Not with the calculator. Calculator doesn't care if you do it anyway. If you want to evaluate a definite integral, you don't have the function, you just have a graph, and you're going to use area above minus area below. That's when the upper limit has to be greater than the lower limit. But if you're just going to get the antiderivative and plug in the upper lower subtract with the first fundamental theorem of calculus, it doesn't matter. You can switch them and negate it. Okay, it'll be the same. The only time you have to, though, is when you're evaluating a definite integral using area. You know. Yeah. Oh, originally, the x value of your given point has to be the lower limit of integration. All right, as long as you keep this plus. So whatever those have to match. Yeah. So we're saying that we're given the derivative of a function. We're just trying to find the y coordinate on this graph. We don't even know what the function is. We can get the y coordinate on the graph at this other x value. So yeah, it can be negative. Okay. All right, let's talk about the homework. One thing that was unfortunate. Oh, I didn't check it. Oh, and you know what? I need somebody who's not on a leash. Well, you know what? Can you hit the pause for me? Okay, guys, the one thing with your homework problem number 1, the graph was so faint that you might not have realized that it started over here. I think you only saw this part, so that might have been really confusing. Went here and then down. All right. So you're given, actually, can you move this thing out of the way here? So you're given that h of x is the definite integral from -2 to x of f of t. And what's the first thing you do in a problem like this? Oh, you could find where it's 0, but you always have to, when you're given an accumulation function, the derivative, yeah, so that you realize that what you're looking at is just h prime. Okay, so you're looking at the derivative of a function, and let's go through the answers. I'm sorry, Ashley, I'm going to have to bug you. Can you go ahead a page? One page. I don't know. It's not like responding to anything. So for the first part, you had to find the zeros. Well, you knew -2 was a 0 because the definite integral from -2 to -2 would be 0, right? But then you want to figure out, are there any other zeros, any other values of x, where if I took the definite integral from -2 to x, I think that was up to t, you get 0. So you have to look at the graph between -2 and see if there's any number where the area above minus area below would be 0 between -2 and that number. And so the answer is 8 there. I'm sorry, I should go back to the graph. Because if you look at this graph from -2 to 8, okay, the definite interval from -2 to 8 is area above minus area below. And between -2 and 8, that's going to give you 0. Because you got 6, you got 4.5, 4.5, and another 6. So balance out. So getting the first 0 is no problem. You just set the limits of integration equal. The second 0, if there's going to be another one, or third or fourth, you're looking, you have to remember that the definite integral between any number and any other number is area above minus area below. Okay, you can go back to the next one. Okay, and then on part B, on what intervals is h increasing? Did you get that part? You look with some -3 to 3. I don't care if you include the 3 or you don't include it. That's not going to. What is h of 0? H of 0 is the definite interval from -2 to 0. So you got to look at, as long as that lower limit of integration is less than the upper, which it is, just look at the graph and take the area between -2 and 0. You see how it's 6 boxes on yours? It's number 1. Yeah, so that's what the definite integral is. And it's all above the x-axis. So it's just positive 6. You guys know where I know I don't have the graph right here. I'll just draw a little picture. So from -2 to 0. So this graph, which is the derivative, if you take the definite integral of the derivative, which is this f, -2 to 0, it's just the area. Right, we don't have to subtract anything, and the area of this rectangle, if you look at it, is 6. Part D is the part I really wanted to look at with you. Thanks. They want you to come up with an expression for h in terms of x. Well, the first thing you have to do with a problem like this is write an equation for the derivative, what you're looking at. Now, they ask us to do that just for the x's between 0 and 6. And if you look at your graph between 0 and 6, it's just a straight line. How can you write the equation for a line? You need its slope, okay? And what else would you need to write the equation of a line? There's 2 different ways you could write the equation of a line. You could get the y-intercept, because in this one you know it, right? So in yours, you know what the y-intercept is? It's 3. So what's the equation of this part of our derivative? What does h prime of x equal? Right, the slope is -1, so it's -x plus 3. mx plus b. Just look at the graph that you have and you can see it's -1. So once you've written the equation for the derivative, what you're looking at, you just take the antiderivative to get h of x. Every time you take an antiderivative, you're going to wind up with a plus c. So you need a point on the graph of h of x to solve for c. So it's got to be some x value between 0 and 6 that you figured out h of x for. And if you remember in this other part, we figured out h of 0 is 6. Okay, well, 0 is in this interval. So we'll use the point 0, 6 to figure out c for h of x. Because 0, 6 is a point on the graph of h of x. So you plug in the 6 and the 0 and solve for c. So this gives us an equation for the function that we can't see. We're looking at its derivative. So it makes sense that h of x is quadratic, because that part of the graph of our derivative is linear. So if the derivative is linear, you expect the function to be quadratic. Just made it very sad. All right, let's look at the other one, because some of the parts kind of repeat. In 4, you have another graph, all right, which you guys have in front of you, hopefully. And now g of x is defined as the definite integral from 1 to x. So again, First thing you do is you take the derivative, so g prime of x is equal to f of x, what you're looking at. So find the zeros of g of x. Questions on that part? See that 1 would be a 0 because it's definite integral from 1 to 1. That's 0. Why would 7 be a 0? Why would the definite integral from 1 to 7 of f of t equal 0? Do you see the graph in front of you? The areas are going to be this. Yeah, the area above and below are the same between 1 and 7. So area above minus below is 0. Yeah. You eyeball it, and then you get an idea where it's going to be. Yeah. Yeah. Very good question. Okay. I'm saying the reason x equals 1 is a 0. I could have said the definite integral from 1 to 1 would have to be 0. Because whenever the upper and lower limits are the same, you know the definite integral equals 0. 7 is also a 0. And I know that the definite integral from 1 to 7 of f of t equals 0 because to find the definite integral of a function from 1 to 7, if you have the graph of the function, you look at the graph between 1 and 7 and you find the area above the x-axis and you subtract the area below the x-axis. And if you look at that graph, you'll see that you do get 0. Can you, I think you have to go ahead and look at a couple of slides so I can see the graph. Might be in a few. Oh no, maybe it's back. Oh no. I think. Okay, yeah. It's like okay, I got it. Alright, so you have a graph of the derivative. So it starts at 1, it goes down to 3, it comes back up here, it's 4, and then it goes down a little more. So this is 7, and this is 8. Okay. But this is the graph of f, okay, so which is g prime. When you want to find the definite integral from 1 to 7, you look at the graph of this function, f of t, which is what that is, between 1 and 7. Okay? So you see first how the derivative is negative. Your function's decreasing until you get to 4. Now at 4, the derivative is 0, f is 0. That was your question? Okay. Yeah, so you can't see the original function. You know it's 0 at 1. You know it's increasing by this, I'm sorry, you know it's decreasing because the derivative is negative between 1 and 4, and the amount of decrease is this area. So it's decreasing until it gets to 4 by whatever this area is. Then between 4 and 7, the derivative is positive, so it increases by that same amount. So by 7, it's back to 0 again. I know the curvature, I'm doing a couple things, so don't worry about that. But then, from 7 to 8, the derivative is negative. So it decreases by how much? Whatever that area is, which is 3/2. So I'm sketching a graph of the function from the derivative. Okay, let me just see if there was other things in here. You asked me the endpoint. No, I do want this one. Can you slide it down to C? C is a good one. Where is the absolute min of G? An absolute min can occur at an endpoint or at a relative min, where the derivative changes from negative to positive. That's why the only x values you even have to consider are 1 and 8, the endpoints, and 4, where the derivative, what you're looking at, goes from negative to positive. You see where I'm getting those from? No? You do see it? Or you don't? Oh, you, okay, so with the graph, if you look at the derivative of g, it feels like, I have it upside down, don't I? So it goes negative. gone from, correct. So if you're going to have an absolute min, it has to occur at an endpoint, 1 or 8, or where you have a relative min at 4, where the derivative is going from negative to positive. So if we get those y coordinates, we'll just compare them, and the least will be the absolute min. To get those values, those y coordinates, you got to use the definition. To get g of any number, it's a definite integral from 1 to that number. So 1 is the easy one. Definite integral from 1 to 1 is 0. But to get g of 4, that's the definite integral from 1 to 4. You got to look at the graph of the derivative from 1 to 4. Area above is 0. Area below is 9/2. It's the area of a triangle is 1/2 the base, which is 3, times the height, which is 3. 1/2, 3 times 3. So g of 4 is negative 9/2. To get g of 8, that's the definite integral from 1 to 8 of f of t. So I got to look at the graph of f of t between 1 and 8. Take the total area above the x-axis, which is also 9/2, and subtract the total area below the x-axis. Well, if you figure out this triangle over here, that's 3/2. So altogether, you wind up with negative 3/2. That's area above minus area below. Negative 3/2. And then you compare those y coordinates, and the least is the absolute min. So that's why it's negative 9/2 and occurs at x equals 4. And then, yeah, part D is like the one we were talking about before. Oh, no, it isn't. Whoa, no, yeah, tangent, that's a big one. If you have to write the equation of a tangent line to the graph of g at x equals 2, it's y minus g of 2 equals the slope u prime of 2 times x minus 2. How do we get g of 2? How do you get g of 2? The graph, right? You got to look, you have to take the definite integral from, I forgot where this one started, 1 to 2. You have to look at that graph from 1 to 2, area above is 0, area below is negative 3/2. I mean, it's 3/2, so it's negative 3/2. So g of 2 is negative 3/2. So you get g of 2. What about g prime of 2? What's that, say that again? You just look at the graph, because that's a graph of g prime. All right, that's where the negative 3 came from. Yep, how to get which one. G of 2 is the definite integral from 1 to 2 of f of t. So you look at the graph of f of t between 1 and 2, right? And it looks like, yes, so 1/2 base times height to get that area. E was the one that's similar to the one we just did. You want to write an equation for g of x between 2 and 6. Start out by writing an equation for g prime, what you're looking at, that line. So you can pick any point on that line. I picked 4, 0 on the graph. And write the equation for g prime. And then you can take the antiderivative and solve for c. Oh, yeah. The y-intercept, it's not going to be obvious looking at that piece, is it? So I would use the point slope form. You can pick any point on the graph of g prime, what you're looking at. I picked the point 4, 0. I had to figure out the slope of it was 3/2. Do you see that on it? So use the point slope form. So to write the equation of that line, it's y minus 0 equals the slope times x minus 4, and then I just solve for y. So that's what g prime of x is, 3/2. Oh, I distributed the 3/2. That's where, that's why it's minus 6. All right, yeah. I'll get to the other stuff. I think I'm boring you with this stuff. But, and then the average value of g prime, the average value of any function, that's that mean value theorem. 1 over b minus a times the definite interval from a to b of the function. And to get this, I use the areas. I use the area above minus the area below between 1 and 8. And that was negative 3/2. No, you don't like that one? Forgot that maybe the mean value theorem, we haven't talked about it like a week. Maybe that's why. Well, part E, they want us to write the equation for a function we can't see. So we start by writing the equation for what we can see. And when you look at that graph of the derivative on that interval, it's just a straight line. So you look at that line segment and you say, well, what's its equation? Yeah, only from 2 to 6. Yeah, they can only ask you to write the equation if it's linear. You can't just look at something and write its equation. So yeah, once you get that, you just take the antiderivative of that to get g of x. Okay, can you switch to, was that the last one of this one? Oh, okay, can you switch out of this? So yeah, and go to the 83. Should be in the, yeah. Okay. Hopefully when we finish this, it'll help you out. Once you get used to these, they're so fun. I can't even tell you. What letter were we up to? F? This is the giant problem in day 83. We're up to G. All right. Oh, do we finish F? Nice. All right. Now, just to recap, this is a graph of F, which is the derivative of G. All right, we're looking at the derivative of G. And then, oh, that's fun. And part G says, on what intervals is G concave up? Where it's increasing, where G prime is increasing. See, that's our justification. So we're looking to see where G prime is increasing. Right, wherever G prime is increasing, the second derivative is positive, so the function is concave up. All right, so what would you say here? Take a look at that. Gina. Nice. Now, as far as whether you, oh, negative 3, make it open or close, it doesn't matter. It's increasing from negative 5 to negative 3. Now, you might say at negative 3, is it increasing or decreasing? It's okay if you include it in either. So if you want to keep it closed, you can. That one doesn't matter. I would definitely include the negative 5, but negative 3, guy can go either way. No. All right, so that's one interval, and then another interval, so we'll use a union here. What would anywhere else? 1 to 2. I'll keep it all closed. 1 to 2. And it wouldn't matter if you didn't include the 1 and the 2. Okay? Questions on that one? Do you remember that? That functions concave up when the first derivative is increasing, when the slopes are increasing as you go left to right? Yeah, you gotta know that chart. Nice. On what intervals is G concave down? What are we looking for? Decreasing? Alright, so we're looking where G prime is decreasing. So tell me, where is that? Okay, so from negative 3 to 1. Yeah, it keeps decreasing, doesn't it? Okay. I guess I'll just include it. Alright, and nowhere else? 2 to 4. The justification is that we're looking where G prime is decreasing. Questions? What's bugging you? Something was bugging you, tell me. No. Where does G, and again, this is G prime, it's not G. Where does G have a point or points of inflection? Nice. You can look where G prime is a max or min. Because you're looking where the slope of G prime is changing. Because the slope of G prime is what? derivative, right? So if you know point of inflections where the second derivative changes sign, you have a point of inflection when the slope of g prime is changing sign, when it's going from positive to negative or negative to positive. Or just think where g prime has a max or min. So where would that be? X equals negative 3, I'm buying that. X equals 1, I buy that. And x equals 2. Okay, what about here? At 0. Yeah, slope's still negative. So the slope's not changing sign. So the second derivative's not changing sign. I tried to trick you. Oh my goodness. At x equals 2, the second derivative, the slope of this would be going from positive to negative. So the second derivative would be changing sign from positive to negative because the slope is positive before and negative after. And it's a max. Let's think this that way. Find the average rate of change of g on the interval from negative 3 to 2. Average rate of change. Slope formula. Bam! Yeah, so I'm going to have to get g of 2. Rate of change, guys. Think ratio of change. Just remember that means slope. So g of 2 minus g of negative... Oops, what did I write out? Minus g of negative 3. So we need to find the g of 2 minus g of negative 3 over... Ooh, what order? Should I write negative 3 minus 2 or 2 minus negative 3? You know, with the slope formula, I'm sure all your math teachers always said, make sure you keep the same order, right? Oh, g of 2. Oh, boy. How am I going to get that? I have no idea what that means. All right, how are we going to get g of 2? How with the graph? Bam. G of 2 equals the definite integral from negative 3 to 2 of f of t. What? So to get, we're going to have to figure out g of 2. So to get g of 2, according to this definition, it's the definite integral from negative 3 to 2. And to get the value of a definite integral from a graph, you look at that graph between negative 3 and 2. So from negative 3 to 2, right, forget about everything else, and we need to take area above minus area below. There is no below, so below is 0. So we just need to take the sum of this area. Do you remember what that was? 4.5. Did we find out the sum of these areas? What was that? 2 minus pi over 2. Nice. So if we take 4.5 plus this area, 2 minus pi over 2, we give g of 2. So 4.5 minus, I put in parentheses, 2 minus pi over 2. Oh, plus, I'm sorry, plus. Oops, so I don't need the parentheses. Yes. So the definite integral from negative 3 to 2, area above minus area below. It's all above. So we just got to add up these areas. The area of this trapezoid we figured out was 4.5. The area of this piece over here was the area of the rectangle, which was 2, minus the area of the semicircle, which was pi over 2. So the area of this was 2 minus pi over 2. So we add this area, 4.5, to this area, 2 minus pi over 2. Oh, this isn't allowed for. Can you just move that for me? The recording. So we have 6.5 minus pi over 2. That's what g of 2 is. No, you're tired. I'll get the g of minus 3. You want to take a break? Take a little break? Just like to do nice things. Alright, g of negative 3. That's to 0. Definite integral from negative 3. I'm not even going to write it. It would be the definite integral from negative 3 to negative 3. We just know that's 0. Wow. Next time I give you anything. Alright. Oh. Just having a bad technology day today. Thanks. Alright, so now we can get it. Because it's g of 2. Let's rewrite that g of 2. I think I had 6.5 minus pi over 2. Let's combine those two fractions. So 6.5 is how many halves? Or 13 halves. We could write that as 13 minus pi over 2. You liked it the other way? Yeah, but you have to divide that by the change in x's. Yeah, okay. 13 minus pi over 10. Well, it would just make it a little easier. Oh, on the AP exam, you don't have to simplify any arithmetic. Yeah. And speaking of the AP exam, everyone knows those checks in that yellow form, that's due on Friday, so you have to have the yellow form filled in. Yeah. No, definitely you're not going to do the last one. Yeah, the bit of a challenge one, forget it. Try the other ones. Where are the answers to every single one of these AP questions? Online, you can either go to the College Board website, but if you just type in Google AP Calculus AB, put the year, you don't have to do that 2011 a bit of a challenge. See what you can do, because you need to practice them. They get to be so much fun. You just got to get into them. Why is this happening, though? Why would it happen?